Alright then, today we're going to be doing today we're going to be doing a new challenge. The challenge that we're going to be doing today is going to be ASM, which is a Pwnable.kr challenge, which is very similar to a hacked box challenge that we did beforehand. And I'll explain why. So let's get started. So with this challenge, as soon as you sign in, you get something similar to ASM and Pwnable. You sign into a directory given the credentials you're given, and then you retype ls, and we're giving 1, 2, 3, 4, I think 4 files. Yeah, 4 files. So we get file ASM. It's an executable file, but pretty sure we don't have access to it for the most part. So ASM. We get this error. We get this prompt. Welcome to the shell coding practice challenge. In this challenge, you can write x64 shellcode under CCOP sandbox. So we're this time CCOP sandbox. This is similar to a challenge that we did in Hack the Box previously. It says try to make a shellcode that splits flag using open, read, and write system calls only. So it's telling us right away that we only have the open, read, and write system calls. That's the only way we could solve this challenge, using open, read, write system calls. If this does not challenge you, you should play ASG challenge. So give me your shellcode, and I'm guessing we input shellcode inside here, and then we get illegal instructions core dump. So we have to insert shellcode using only the system calls open, read, and write. So I guess the approach to this problem is for the most part, which is pretty easy if you've never done this, but what you want to do at the beginning is first, as you said, you open the file file name. After that, you read in the content of the file. So you read in the content of file, and after that you want to write it out towards you so we could see it, what's inside the file. So write out the content of the file. That's basically the whole point of this challenge. Basically, like I have over here, you open the file, you read it, and you write it, which is basically easy, which what we're giving. So the whole point of this is to write shellcode. So like write like assembly code for the most part. But there's an easier way to do this. So with Pwn recently, they have a feature in which you're able to do it very easily. So in my case, I already have it set, but I guess I'll try explaining how I came up with this, because I already did this challenge beforehand, and also I've done similar challenges right like this where we're only given the open, read, and write permission. So I have it right here. So right here, this is basically the script I use for the most part. So more conveniently, we could set up, prepare, and test it with the local and reads flag and dumps into the screen. So if we actually wanted to write a shellcode, it'll be something like similar to like this, where we had to write assembly, but Pwn makes it a lot easier for us. So basically all we need to do is open it using shellcraft. We open the file, pass in the file name, then we read it in. What does this 3 mean? I guess you're asking yourself. So if we look at handling files by descriptors and see, we have 0, 1, and 2. 0 stands for standard input, so inputting data, taking in data. 1 is for standard output, for outputting data, which we're going to use later. For if you check right here, go back to our Pwn tools. To write it, you write it out to 1, so that means it's 1. And then 2 is for standard error. So in this case, we have 3. So 2 processes can occur having the same file open. Process A can access for. So if you see right here, process 3, or the 3 descriptor, all it does is point to the file. That's basically it. So that's why we have 3 right here. It reads in the RSP, which is a stack pointer. Stack pointer is the top of the stack. So RSP images assembly or stack. So the RSP is gonna be the top of the stack, but in this case it's the bottom. But I'm trying to find it better. RSP is whatever is at the top of the stack for the most part. So RSP, is this a better example? The stack pointer. So whatever's the top of the stack. So in our case, the top of the stack is gonna be the file name. That's the last thing in the file. So right here, all we're passing is the read, which is 3, which is, I guess, the file. RSP, the file name. And then this read is basically this, how much we want to read in for the most part. How much we want to read in. So if we look up shellcraft read, we could actually look at, or I have it right here, read. So read data from the file descriptor in the buffer. This is a one shot and does not fill in the request. So count, in this case, it's reading in as 0, which is standard 0, standard input. It wants to read it in from standard input. And then after that, RSP is just a stack pointer, so whatever the file name is. And then count, it's only reading in 8 bytes. That's basically it for the most part. But in our case, we're using 3 because I guess we're opening the file. And since it's already opened, we could just use 3 for the most part. So if we check our code right here, cat solve.py, what we have here is from pwn import. So then we have context.binary. Why context.binary? So with pwn tools, how will pwn tools know what kind of binary is, what kind of binary it's gonna be? So that's why I have context.binary. So for context.binary is just for assigning it's just for pwn tools or Python to know for the most part what kind of file it is. And then after that, since the file name, which is this what we're trying to read, since we don't have permissions to read it for the most part, and I think I could go back to it. Cat this is Pwnable.kr. Oh, this is a fake flag for letting you know the name of the file. Okay, so this is a fake flag, but we start to connect to something else. So if you go back to temp cost, so this is a fake flag because we're connecting to something else for the most part. But cat solve.py. Okay, so this is the file that we're trying to read that's remote somewhere. And then the length, how much we want to read is 50, but this could be changed to anything for the most part. This could be like 100 or 200. It doesn't have to, we just assume 50. So ASM, this basically puts these all together. So we open it, we pass in the file name, the stack pointer is the top of it, 3 is for the file because it's already, the process is open, and then we get the length. So the length could be anything for the most part. It could be 100, 200, but if it's too little, we're only going to get a little bit of it. And I guess I'll show it right now. Then we write it out. Right when we write to standard output. So we output it out. RSP is basically the stack pointer, which is the file name. Length is just how much we want to write out. And then after that, we just exit out. And then we connect to a remote server, because if we look back right here, we see, oh no, it doesn't show right there, but if we go back to cd home, then we cat readme, we see once you connect to port 9026, the ASM binary will execute under ASM PW privileges. So we have to connect to a port within this shell, within this SSH server, I guess. So cd tmp cost cat solve.py. So within this, we connect to I guess a port only access inside this SSH server. So we connect to it, and then after that we get whatever it's outputted to us, and then we just send we send our shell code, and after that we print out whatever we receive. So we send out our shell code, which is what I guess .asm is. Oh, wait, well, it's not right here, but it was in the previous one where it says send shell code, and after that we print out whatever it's asking for us for the most part. So that's basically it for this challenge. So all you need to know is, like, you could write it in assembly for the most part, the entire thing, but you could just basically use the open, read, and write. So let's see this. So Python 3 Python and then solve.py. So we see right here, so look at this. The context.binary is AMD64. So context.binary, it sets it as an AMD64. It tells Pwn tools and Python that it's working with the AMD64 file. And after that, welcome to shellcode. Try to make shellcode. And then after that, we send it our shellcode. And then wait, what? Did it mess up? Let me check. A nano solve.py. From pwn context.binary. Did I mess up something? I might have messed up something. 3 RSP. Because it... I might have deleted something, but I can't. Yeah, I might have deleted something by accident, but the good thing I have my code right here. It might be the file name I might have messed up, but who knows? No, it can't be. ls rmsolve.py ls nanosolve.py. Yeah, this should work. Python solve.py. Yep. Give me your shellcode. Close connection to port 90206. P remote, P receive, P dot send line. Oh wait, I just forgot to put another print. Send that. It was working for the most part, so if I just forgot to put another one of these. Oh yeah, so see, look, it printed. I guess I deleted an extra print, but it says right here, making shellcode is very easy reading this file. So this is what we have so far. But what happens if we change the? I guess I want to show what happens if we change the length of it. Let's see if we change it to 10. So I'm guessing if we change it to 10, it's gonna receive less. Python 3, and we get. See, look, making she, and let's see, we could probably get the size of this if we just like put Python 3. All right, Python, and then we just get the length of this, and we just put this here. We could do length, something like this. Oh, length, and that's basically 10. So that only reads in 10. So if we just change this to exit, nanosolve.py. So we just change this to like what, 50? Let's change that to 100. I don't think it'll matter. If it does, then oh well. Python 3 solve.py. So we should get the entire thing right now, and we did. Oh, this is the file. Give me your making sure. Sorry, the file name is very. Oh, so it's way longer than that. Oh, so solve.py. Let's make this like 200. Let's make this 400 because this is like super long and very long. So it's probably all the way up to here. This is where the flag reaches because this is just pure like I guess, oh, it went past this. So this is not nothing important. So for the most part, it's probably just all of this for the most part. Please read this file name. Sorry, the file name is very long. So yeah, that's the whole point of the length thing. But anyway, that was about it for this challenge. Hopefully you guys learned something new today. I know I did. It's a pretty cool challenge, pretty good refresher. Anyway, yeah, that's about it for me. And anyway, peace.